go. So when we left off at the break, we were just getting cozy with these trig functions, getting associated with them. So we know that theta is this thing right here. It's an angle measure we don't know, and we can apply these things to theta to get different values. And so what it does is it relates the angle, theta, to the sides of the triangle. So sine relates the sides of the triangle like this. It relates the opposite side, which is opposite theta, directly across. This is called the opposite side. And it also relates the hypotenuse. Now, which side is the hypotenuse? The 3, the 2, or the 5? The 5, because the hypotenuse is always the biggest side of a right triangle. It is also directly across from the right angle, always. So it relates the opposite to the hypotenuse. So sine of theta is going to be whatever the opposite length is over the hypotenuse length. So hype on the bottom, opposite on top. And that's what sine does. So the sine of this theta would be 2 over 5. 2 over 5, opposite over hypotenuse. Cosine, on the other hand, is very similar to sine, as you might imagine, given that it is cosine. It also has hypotenuse on the bottom. But instead of opposite, what do you think it has? This side right here. We're going to call that the adjacent side. We call that the adjacent side because it is next to theta. And you might say, well, this guy's next to theta too. That's true, but he gets a special name because it's a right triangle. That's the hypotenuse. Okay? So the adjacent means next to. So for instance, adjacent to Mr. Moore on his phone is Carson on his phone. They are adjacent to each other. Opposite Mr. Moore is Mr. Wheeler, who is not on his phone right now, but is listening to some tunes in one of his ears.
What you listening to?
Carson, where you?
Gotcha. So adjacent means next to. Opposite means across. Okay? Hypotenuse is the biggest side, the most important. So the Amelia of that table. So the most important is the hypotenuse, and then we have theta, opposite, and adjacent. So the adjacent goes over the hypotenuse for cosine. Our last trig function. What's our last trig function?
Tangent.
Tangent, thank you very much. Tangent of theta, again, taking that same angle. Tangent is going to be the opposite over the adjacent. Now, how do you remember all this, right? How do you remember what goes with what? There is a saying. Who remembers the SpongeBob episode where they're all superheroes? You have the Quickster, right? The Quickster. You want to see me run to that tree? Let's see me do it again. Krakatoa is what Captain Magma says. Who's Captain Magma? Come on, guys. Squidward, right? So he says Krakatoa, which reminds me of this thing right here. Also in Finding Nemo, you know Wanahakalugi, the mountain, the volcano? Wanahakalugi, right? Yeah. Kind of reminds me of this thing right here. So sine starts with an S, yeah? And it's opposite over hypotenuse. So S-O-H. We pronounce that so. So. Cosine starts with a C. And it's what over what? Adjacent over hypotenuse. You might have heard this one. And then we have tangent, which starts with a T. And it's opposite over adjacent. So altogether, the mnemonic to remember is SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And that's how you remember these trig ratios. SOHCAHTOA. Everybody cool with SOHCAHTOA? Have you heard it before? Yes, some of you have. It's kind of like the Pythagorean theorem, where even if you don't know much about geometry, you might have heard it before you took the class. It's kind of a common thing. I think in a lot of TV shows they talk about it when they are referencing trigonometry. But that's that. So let's have some fun. Let's play a game. Get out some graph paper, if you would, from over in the bin. Here's the bin. Sorry, I need to turn off more. Go get some graph paper. Appoint somebody to go get it for you if you need to. Sorry, it's all crinkled. We'll get rid of it and get the new stuff tomorrow.
Dave, there are two.
It's not anymore. That's from last semester. It'll be fixed when I print off new stuff.
Yeah, actually I do. Oh, wait, whoops, it's not graphic. Dang it, I thought it was like half graphic or half.
All right, so I'm giving you a triangle. We know that it's a right triangle, and I'm telling you that this angle right here is theta, the angle I'm referring to, the reference angle, if you will, the one we're going to refer to. So there is theta. If that's theta, I want you to label the rest of the triangle opposite, adjacent, and hypotenuse. Tell me which sides are which. Label them now. Label each side of your triangle. Make sure you're careful. Remember, theta matters. Where theta is. Think about what it means to be the opposite side. Think about what it means to be the hypotenuse. Adjacent's the one I usually fill in last. I want you to do that now. Our triangle from before looked like this. Remember, theta was down here. Now I'm saying theta's up here. Give you a couple more seconds. We'll try to figure out what you guys thought. We still getting good sound? We are getting decent sound, I suppose. Turn up this gain a little bit. All right. All right, so let's start with the hypotenuse. I think that one's the easiest one to label. Where is the hypotenuse?
That big line.
It's the big one right here, right? So this is the hypotenuse. The hype. Like Flava Flav, the hype man. You don't know who Flava Flav is? You got to check out Chuck D and Flava Flav in Public Enemy. Not Waka Flocka. Although that is an excellent show, if I think I know what you're referencing, right? All right, so which one's the opposite side?
The
Bottom one, because it's opposite theta. It's opposite. It's what the angle opens up into. Which means the adjacent must be this vertical side, right? Adjacent, kind of like adjective. All right, cool. So now, if I told you this was, let's do 10, let's do 8, and let's do 6. So this is 6, this is 10, and that's 8. I want you to write the sine of theta. I want you to write the cosine of theta. And I want you to write the tangent of theta. So given those numbers, what will they be? Remember SOHCAHTOA? I'm probably going to run out of room to write those fractions. But remember, sine, cosine, and tangent relate the sides of the triangle to the angle. So on one side you have sine and the angle, and the other side you have the sides being related. The ratio between the sides. Sound it out if you have to. Natalie, Mr. Boyer, your responsibility now.
I'll take him on the line. Show him the way.
Thank you. Mr. Dively, I'm questioning your location right now.
Oh my God.
All right, so who can tell me what sine of theta is? It's the what over the what? You said 6 and 10, so it's the opposite of the hypotenuse, which is true. So, right? So 6 over 10 is what we get. I'll do that in the proper colors. So we have 6 over 10 is the relationship. We can reduce that. Do I care? Not really. But if you wanted to, what would you reduce it to? 3 over 5. 6 over 10? 3 over 5? All right. Grace. Cosine relates the what to the what? Yep. The adjacent to the hypotenuse. So our adjacent is 8, and our hypotenuse is what? 10. Notice that sine and cosine have something in common, right? The bottom is the same for both of them. That's why this is called the cosine. So, if I were to reduce that, I get 4 over 5. Okay. And the tangent of this angle is going to relate the what to the what? The what over the what? Opposite over adjacent. Not the other way around. TOA. Opposite over adjacent. So we get 6 over 8. What can that be reduced to? 3/4. Cool. So that's that. That's all there is to it. What if I gave you something like this? What if I told you that the sine of theta equals 5 over 7, and I gave you a triangle like this, and I asked you, no, I don't want that. What's the length of AB? And what's the length of BC? And what's the length of AC? Could you find the sides? I want you to think about it for a while and try it on your own. Think about it. How can you take that information and find the length of AB, BC, and AC? AC might be a little tricky. You might have to think out the box a little bit more. Takes a little thinking outside the box to know what you're doing from the start. AC takes a little bit more thinking outside the box. Try it. It is a triangle. And I'll tell you it's a right triangle because that's the only way we can use sine, cosine, and tangent. At least as far as you know. Give you a minute or so, and then I want somebody to explain how they found A, B, and BC. Like, explain the full process. The insight that you need to have to be able to do it, how you came up with it, and we'll have somebody else explain how they found AC. I think a lot of the issue I'm seeing from some of you guys, it's true more so for my algebra class than it's geometry. Write the problem down first. If you don't do that, it's hard to do it. And then two, writing it down might give you a little bit of insight. At least start there. All right, somebody give me a hand and raise your hand and tell me how you found A, B, and BC. Like, what do you have to know to be able to do it, and how did you go about it? Mr. Dively, was that a hand?
No, but I guess.
If you want to volunteer, go ahead. I won't make you volunteer.
We know Sine, so Sine theta.
Send of my Sunday school teacher. Yes.
Since you know what so the subtotal is, we figure out that it's opposite over.
Yep. Sine is always opposite over hypotenuse. And I usually like doing OP or OPP so it doesn't look like a zero. and then hype. So if the opposite side is 5, where's the opposite side? Here's theta. Somebody tell me the opposite side. AB is the opposite side, so the opposite side is 5. And the hypotenuse is the one across from the 90 degree, right? So that one, it must be 7. All right, so AB we found out was 5. Are you seeing this now, Stryker? How we got the numbers? Okay. And we said BC was 7. Now, how do we find AC? Because this doesn't tell us anything about the adjacent side. It doesn't tell us anything. How can we find AC? Anybody clever enough to figure it out? It's okay if you didn't. Joey. Pythagorean theorem. So we do 5 squared plus whatever this is squared. Let's call it x. X squared should equal 7 squared. Remember, the 7 goes after the equal sign. It's C because it's the hypotenuse. So it goes here, not here. So how do we solve the problem like Maria? What's 5 squared? 25. I'll do it in black. What's 7 squared? 49. Now what do we do? Subtract 25 from both sides because we're trying to get x on its own, right? And that's what's bothering x. We save that square for last. Just like in PE. 49 minus 25, 24. And then what do? We root it, so x is going to be the root of 24. Let's practice with reducing that root. Would I care if you left it that way? No. But it's important to understand this stuff. It might give you a better insight on what's going on. Let's reduce it. I can break down 24 into what? 6 and 4. I can break down 4 into 2 2's, and I'm done. What about 6? 3 and 2, and they're done. So inside the jail, I have 2 times 2 times 2 times 3. Remember, just like jail, you have to find somebody who looks like you, take them out, and escape in their body bag. So they're outside the jail. The 2 and the 3 have no one to look that looks like them, so they have to stay in. So the answer is 2 root 6. The 2 and the 3 multiply, because that's what happens when you stay in jail. So 2 root 6 is our answer down here for AC. And we use Pythagorean theorem to find it. I would also accept root 24. So there you go. Let's try another one of these. We're going to start at the top, just like before. You're going to identify the sides. Then you're going to tell me this. And then I'm going to give you one of these. So let's do another one. There's theta. I want you to label opposite, adjacent, and hypotenuse. I'm going to tell you that this guy is 5, this one is 3, and that one is 2. Label your sides. I'll give you 30 more seconds to do that. Label opposite, adjacent, and hypotenuse. Please pick up your pencil at least and look like you're working. If you have questions, raise your hand. Label which side is which. Today is not the day to nap, guys. You gotta understand the stuff, but we're gonna do the stuff for the rest of the semester. Cosine. So same thing with sine, just with CO in front of it. If you're done with that, move on and tell me what the sine of theta is, what the cosine of theta is, and what the tangent of theta is. Go ahead and tell me that. Yeah, let's draw a triangle here. Not bad. Better this time? Yeah. Okay. I'll take that every day. Congratulations. subway. Olive Garden. Olive Garden. Okay, that's like the richest thing out there. You go to Olive Garden, oh man. All right. Big spender, big spender. All right, so.
I love breadsticks. Where at?
All right, so which side, the 2, the 3, or the 5 is the hypotenuse? The 5, because it's opposite the 90-degree angle. Hypotenuse. The hippoponymous. All right, so which one is the opposite side from theta? 3, it's opposite. It opens up into it, so that's the opposite side. And then our adjacent side goes over here. Cool. So if that's true, sine should be what over what? 3 over 5, because it is the opposite over the hypotenuse. So, and then we have cosine should be the what over the what? The adjacent over the hypotenuse, so 2 over 5. Oops, I wrote h instead of 5. And then everybody, I want you to think about it, and then I want everybody to tell me. First off, tangent is the adjacent, opposite over the adjacent. So it's going to be what over what? 3 over 2. Very good. All righty. I'm going to give you this. I'm going to tell you that tangent of theta is 12 over 5. Tangent of theta is 12 over 5. Here's your triangle. Label the sides. I want you to tell me what AB is, AC, and BC. I don't know if that's a good order or not. It might not be, but I want you to find all 3. Do that now. I'll give you 2 minutes. And then we're moving on. I'll give you a hint. Tangent is opposite over adjacent. SOHCAHTOA. So here's theta. The opposite side to theta is AB. So what's AB going to be? 12. The adjacent to theta, well, this is the hypotenuse, right? So the adjacent must be this one. So how long is the adjacent? 5. And that's BC. So we need to find AC. We need to find the hypotenuse. So how are we going to do it? What are we going to use? Bueller. Pythag. This guy squared plus this guy squared should equal the hypotenuse squared, which is what we don't know, right? So let's call that x. That's the hypotenuse. What's 12 squared? 144. And 5 squared is 25. And that's going to equal whatever x squared is. What does 144 add up to with with 25?
169.
Nice. And then we root it. Now maybe you don't know that's 13. Let's break it out of jail. Root 169. I can break 169 up into what? Is it divisible by 3?
No.
It is not. We have 7 plus 9 is 16. That's not divisible by 3. So it's not going to work. Is it divisible by 2? 3. We already said no. 4? Can't be. 5? No. 6? No. If it's not divisible by 2 and 3, it doesn't work. What about 7? No. What about 8? 9? 10? 11? 12? 13. It's a perfect square. So we have 13 times 13 inside here. 1 dies, 1 gets out, nothing in the jail. So it gets demolished, or I guess it's not 0, but nothing's in the jail, so we get 13. 13, it is a perfect square. All right, so how do you feel? Not too bad, 75% good, decent, somewhere around 75. Clara, how you feeling? Good? Wonderful. All right, so now that we've established sine, cosine, and tangent, we need to talk about their opposites. Because remember from before, I told you we had these operations, right? Plus and its opposite minus. What's the opposite of multiplication? Division. We have the opposite of squaring a number, which is rooting a number. And then we have the trig functions, which I didn't label. But we have sine of theta, the opposite of sine. The way to undo sine. Not cosine. Inverse sine is what they call it. So we call this inverse sine. Inverse means to undo. So it's kind of a simple name for it, right? We could call this inverse addition, right? Inverse multiplication. Inverse squaring. Another name for it, which a lot of people like, is arc sine. Arc sine. Which sounds like the next teen novel to hit the shelves. All right.
Straight.
What's up?
It just has that little thing. That's the only difference.
Yeah, it's got the -1 to the negative first power up here. It's like we're squaring sine, except it's to the -1. Good question, good question. Cosine, the opposite of that is the same thing. Cosine inverse of theta. It's to the -1. It's like an exponent, but it's to the minus first power. And then tangent, you guessed it, inverse tangent, or arctan. Those are the opposites. So why is this useful? Well, it's useful for this reason. If I tell you that the sine of theta is a half, well, we can imagine a triangle, right? Here's a triangle, there's theta because I said so. Opposite is 1, hypotenuse is 2, right? And we can find that third side with Pythagorean. But what if I want to know what theta equals? Well, if that was x, we'd know what to do with it, right? We got to get everything away from x and get x on its own. But it has sine next to it, so we have to undo sine. And you guys know how to undo sine. We do arc sine, right? Or inverse sine. So here's how you do it. Here's your original problem. And remember, algebra says as long as you do the same thing to both sides, like if I smack Lucas in the back of the head, it's okay as long as I do it to Joey as well, right? That's algebra. We have to do inverse sine to both sides of the equation. So we do this. I know it looks weird, but remember, they undo each other. So sine inverse and sine go away. And we're left with theta. And then sine inverse of a half, you plug that into your calculator. It's going to be some number. I'll show you how to do that now. And that's going to give you the angle measure of that angle. It'll give you a number for an angle. Let me see if I can find a calculator that will work. Earlier I couldn't find one that had a good battery, and then even if it did, pressing the buttons does nothing. Hi.
So you can go
What's up?
I usually shut your face.
Yeah, so those are trig functions, and those are inverse trig
Shut my
functions.
shoe.
So So the trig functions are sine, cosine, and tangent, and the inverses of those trig functions are inverse sine, inverse cosine, inverse tangent, or arc tan, arc sine, arc cosine. Does anybody have one of these TI 30Xs that actually works? Because all of these over here either don't turn on
Yeah.
or don't have batteries. I don't want to.
Oh my gosh, I love those. My brother has one.
Graphic code. All right, so if you have one of these, which everyone should have some kind of access to, more or less. There's a bunch over there that ostensibly work, although we've proven that they don't. On this calculator, if you zoom in closely, you'll notice that we have a sine, a cosine, and a tangent button. We also have inverse sine, inverse cosine, and inverse tangent as secondary options here, right? It's when you hit the second button up here. That's what happens. So if I want to know sine inverse of a half to find what that angle is, theta, I type in second sine inverse, and I get this to pop up. And I type in 1 over 2, or 0.5 if you want, and I hit enter. Turns out that angle is 30 degrees. So if I have a triangle, a right triangle, where the hypotenuse is 2, and the opposite side is 1, then this angle is 30. So what if I gave you this? Cosine of theta equals, let's do, one squared, 4, 5, root 5, is root 5. How would I solve for theta? What do I have to do? Arc cosine or inverse cosine to both sides. Just like we add or subtract to both sides, right? And they go away on one side, and we're just left with theta, which is what we wanted, right? We want to know what theta equals, so we got theta equals whatever cosine inverse of root 5 is. Okay. Well, let's make our triangle before we get going. Here's our triangle. We'll call this the right angle. We'll call this theta, because why not? Cosine is root 5. Cosine's the what over the what? SOHCAHTOA. Adjacent over the hypotenuse. So the adjacent should be root 5. What should the hypotenuse be? Turns out the hypotenuse was there all along. It was just hiding. It's 1. I know. So now let's find out what this angle is. A hypotenuse of 1 and a bottom adjacent side of root 5. What's the angle measure going to be? So I go here. I go second, inverse cosine. Root 5 is what I want. So I go second square and gets me square root 5. And I close off all my parentheses. Domain error. Says it's not possible. Says that I can't have an angle with this here, where this is 1 and this is root 5. Domain error means that the value you're looking for doesn't exist given those restrictions. Can't be possible. But that's interesting. This is 1. This is 2. What's the missing side down here? Yep. But what's the value of that side? The length. 1 squared is? Plus 2 squared is? Right? Right? 1 squared is 1. 4. Then we have x squared. So I get root 5 equals x. So this should be root 5, but it says it's impossible. What did I do wrong? Andrea. 2 should be over here. It's the hypotenuse. This is what we're looking for. So what is actually the length of that side? Figure it out now. Figure out the actual length of this side. 1 squared plus x squared equals 2 squared. What is it? What is it? Oh, you were onto it. I think so. 1 squared plus x squared equals 2 squared. What's x going to be? Anybody? Square root of 3. So this triangle is not possible. We got a domain error. So what if I told you this? What if this was root 3? Okay, so now we have this. We'd plug into our calculator cosine inverse of root 3, and you get that angle. Before you do that, does anybody have any guesses of what it might be? We said the sine of this guy, 1 over 2, was 30. What do you think the cosine of this is going to be? Cosine of root 3. Inverse cosine, I should say. Anybody have a guess? Without a calculator? When we had this triangle up here with 1, 2, and root 3, we said the sine of 1 over 2 will get you 30 for this guy. Now we've got this guy. Root 3, 1. What do you think the cosine is going to get? What do you think the cosine inverse of root 3 is going to be? Well, it's going to be whatever this angle is. Any thoughts? Would you like me to draw a little bit cleaner so you can see it? For the angle? 9? Mm-mm. I'll give you some time. What do you think it's going to be? It might help if you found out this missing side. We have this guy as 1. This guy is root 3. What side length must this be? Are you confused? Because you should be. You're thinking there's some association here. But again, the 2 is the hypotenuse, and now the 1 is the hypotenuse. So it was a different triangle. Completely different triangle. So there's no way to do it. In fact, if you were to plug this into your calculator, whoops, sorry, not sine, cosine of root 3, you'd also get a domain error. This triangle is not possible. One last one, real quick. I'm going to give you the tangent of theta. I'm going to tell you that it is, let's do, yeah, we'll do root 3. Tangent of theta is root 3. If we draw our triangle out, here's a right triangle, here's theta. Tangent is the what over the what? Opposite over the adjacent. So the opposite is this side, and the adjacent is 1, right? Because that's just root 3 over 1. I want to know what theta equals. How would you get theta on its own here? What would you do? Opposite of tangent, which is arctan, or tangent inverse. So we do that to both sides. This goes away, and we get theta equals whatever tangent inverse of root 3 is. Does anybody have a calculator that can do tangent inverse of root 3? See if you can find that. Anybody? If you have a phone, you can do it. Yeah. 60. So that's a 60-degree angle right there. You okay? That's a 60-degree angle. So this is 60. What if I asked you about this guy? That's mu. Or phi? I don't remember. It's a Greek letter. Different Greek letter. What about this guy? If that's 60 and that's 90, what's he going to be? 30. So that means that the sine of this guy, 1 over whatever this guy is right here, what's this going to be? What's the side length? 1 squared is? Root 3 squared is? Add them together we get? Root them we get? 2. So 1 over 2 gets us 30, just like we did on the last page. The sine of a half gets us 30. The sine, or the tangent of root 3 gets us 60.
So the time the half.
So if I did the sine of theta, theta is this guy, right? It'd be opposite over hypotenuse. So it's going to be root 3 over 2. Which means the sine inverse of root 3 over 2 is going to equal an angle measure. What angle measure is it going to equal? It's going to equal 60. Let me show you what I mean a little bit more clearly. If I tell you that the tangent inverse of root 3 equals 60, and it does, you can check it. Draw your little triangle. We've got theta. We know theta is 60, right? And tangent is root 3. So opposite over adjacent. If I want to know what the sine of theta is, what do I need to know to find the sine of theta? I need to know the hypotenuse. What's my hypotenuse going to be? It's going to be 2. So what's the sine of theta? Opposite over hypotenuse. Root 3 over 2. Brainbuster. Sine inverse of root 3 over 2. Remember, sine takes an angle and gives you the side lengths. Sine inverse takes the side lengths and gives you the angle. So what's the angle you get when you have an opposite of root 3 and a hypotenuse of 2? What's the angle you get? 60. 60. All right, let's take a look at the homework.
Wait, homework?
It is convoluted. It is weird looking.
Okay, what's on?
Good. Grow and persevere. I'm sorry for the format of this thing. It looks awful. We'll do number 1 and number 3 together, and then you'll be on your way. Part of this is going to require to use a calculator. I'm not a huge fan of calculators, but you'll be all right. Go to the door. I'll pass them out to you. I will post the rest of the video showing number 1 and number 3, so you have a chance to try it. Page 2 isn't as bad. Give it your best shot. We'll talk more about it on Wednesday. There we go. Sorry that had to give you a wow, rude. That's a problem. All right, so for those of you watching this video still to figure out what we need to do for number 1 and number 3, here's what you do. So number 1 is asking what over Wx is congruent to what over what? Well, Wx is right here, and tangent says it's the opposite over the adjacent. So here's the opposite side of our angle, right? Angle x. or the adjacent side, our opposite's going to be VW. This side right here. So we have opposite, adjacent, hypotenuse. So the tangent of angle x is the opposite of the adjacent, which is VW over WX, which is going to be the same as the opposite for this triangle. So YZ, what's up? And ZX. For tangent inverse of VW and WX, it's saying what angle will that go with? Well, it's going to go with this angle, angle X. And that's all. What's up, guys?
Are you videoing? I was finishing up.
Hey, can I go to the bathroom?